Hi everyone, my name is Priscilla Philbeuman. Today I am going to demonstrate a data science project that I have done as part of an internship. So the name of the project is Sales Prediction using Python. This is the project and this is the problem statement here. As you can see, what we are going to do is sales prediction based on advertising expenditure features such as TV, newspaper, and radio. So I will start this project by importing the necessary Python libraries. Next, I am going to load the data set into Pandas data frame, and I will display the first 5 records of the data set. As you can see, this column name called unnamed 0. This column is not required for data analysis and our prediction as well. So I'm going to drop this column. So I'm going to use the statement called dot shape. So I can see the rows and columns of the data set. So there are 200 rows and 4 columns. And by using this statement also .info, you can also view the information about the data set. Here also you can see how many rows and columns are there. You can see the data types of all the features like TV, radio, newspaper, and sales. And you can see the memory usage as well. So I'm going to check for null values. So as you can see, there are no null values. So it is a clean data set. Next, I'm going to check the statistics. I'm going to display the basic statistics of the data set. So as you can see, this is it. And next I'm going to compute and display and visualize the correlation matrix. The correlation matrix is a table showing correlation coefficients between variables. So you can see I have visualized the correlation matrix by using a heat map. As you can see, this is the diagram for that. And next what I'm going to do is data visualization. So first I'm going to use pair plot. By using that, you can see there are comparisons made for all the features here. And this is by using Seaborn library. And this is a scatter plot. The next one is scatter plot. As you can see, by using scatter plot, you can see the comparison between all the features here. You can see. And next, I'm going to use distribution plot. You can see again there are some comparisons made. You can see the difference between all the features here. You can so next I'm going to plot a histogram. As you can see, this is the histogram. And next I'm going to plot a linear regression plot, since what ML model that I'm going to use for the prediction is linear regression. That's why I'm plotting a linear regression plot. You can see this is the plot of the this is the linear regression plot here. And then next what I am going to do is, again I'm going to visualize the whole data set by this statement. By just calling the data frame, we can see this. And if you click on this icon here, you can see all the visualizations here, data visualization. You can see the distributions and the values and everything here. So what I'm going to do next is pre-processing the data set and model preparation. Again, I will check for null values. So there is none here. So next I'm going to split the data set into test data, training data, and training set and testing set. So as you can see, X variable is the whole data set except the sales column. So we're going to drop the sales column, and the Y variable is just the sales column of the data set. So we are splitting it into training set and testing set, and we are going to use random state 42 because we will get the same training and testing set across different executions, and as you know, it directly affects the model's performance score. And then I will use the label encoder for the y variable, and then I'm going to first I'm going to import it. I'm going to import all the three, the min max scalar, label encoder, and standard scalar. So I'm going to use standard scalar next, and it standardizes the features by removing the mean and scaling to unit variance. So we are going to do this for the x variable. You can see I have showed it here. Then I'm going to import the linear regression model. This is the code for that. As you can see, I have calculated the accuracy rate also. The accuracy for the linear regression model is 89.9 here, almost 90%. And then next I'm going to plot a line plot for visualizing or for displaying the performance of the models. So you can see the performance of the models can be evaluated by the following metrics like R squared score. So that is a measure of how well the model captures the variance in the target variable, that is the sales. And next is mean squared error, MSE, that is a measure of the average square difference between predicted and actual sales values. And the next one is cross validation score, to ensure the model's generalization ability and minimize overfitting. For that reason, this is used here. And as you can see here, I have displayed it here in a form of a diagram. Here you can see the all the metrics are calculated here. As you can see, the mean squared error is 3.17. The R squared score is 0.89, almost it's 90. And then as you can see, the cross validation R2, that is 0.85. as you can see, this is a line plot here. And finally, we are going to do the prediction part here. We are going to predict the sales, and you can see there are some new data. I have made a new data frame here, and the new data for TV is 100, radio is 50, and newspaper is 25. And as you can see, the predicted sales value is 16.98. And as the final part, I'm going to mostly for every machine learning project, the final part will be the confusion matrix. And as you know, it is used to evaluate the classification models. So and you know, it is not used to evaluate linear regression models, so it is not required here. So the final part of my project is the prediction, and it is the predicted value 16.98. And so that's the end of my project. Thank you.